So the two best AI coding models just got an upgrade within about 30 minutes of each other, with Anthropic releasing Claude Opus 4.6 and OpenAI releasing GPT 5.3 Codex. And in this video, I'm going to actually code with these models. They are going to be first impressions, but we're going to be going into an actual TypeScript codebase, an actual Rust codebase, and an actual Java codebase to see how these actually code in the real world, and going head to head on the same task against each other. And I know I haven't made one of these videos in about 6 or 7 months, so I'm going to remind you, I'm not the biggest fan of benchmarks because they can be played. I feel like sometimes there are good benchmark scores and you try the model and it's just garbage, relatively speaking. So while it's fun to look at, it doesn't feel all that useful, to be honest. But there are some useful and interesting things to touch on that they wrote down in their announcements, which both claim to be the leaders of the Agentic Coding Evaluation Terminal Bench 2.0, setting new industry highs. However, unfortunately for Anthropic, theirs only lasted for the 27 minutes that they were out before GPT 5.3 Codex, because as you can see, 5.3 Codex beat out Opus 4.6 by quite a hefty margin, to be honest. But again, benchmarks kind of hooey. But what they said in their announcements, not so much. Claude Opus 4.6 improves on 4.5's coding skills. It plans more carefully, sustains agentic tasks for longer, so just, fights through the pain, I guess, and can operate more reliably in larger code bases, presumably thanks to refinement, but I can guarantee you the improved 1 million token context window does not hurt it, up from the 200,000 token context window that Opus 4.5 previously had. And they say it has better code review and debugging skills to catch its own mistakes. And of course they're going to say that, but they do have all of these benchmarks to back it up if you want to follow the benchmarks. To be fair, they need the benchmarks because they can't just say, yeah, it feels better, it does better, we don't have proof, but believe us, they have to have the benchmarks to at least convey that it's improved to us. Now, I'm not going to read this whole article, but I do want to point out one thing that I am stoked on. Just a day before this was released, I tweeted out, who's building a pair programming agent harness where I can have a couple of the best models work together on a single coding task? Now, that's not exactly what they did, but they did something very similar, which is you can now assemble agent teams to work on tasks together. Now, it's not exactly like my tweet because it's not taking models from everywhere, but it is taking the best Claude models where you can coordinate multiple Claude Code instances and have them work together as a team. So you can have them work on shared tasks. You can have inter-agent messaging to figure out, I don't like how you implemented that. Or actually, I think this is how we should approach that task. And then centralized management. I'm not testing that out in this video, but I'm very excited to do so. As for GPT 5.3 Codex, they took the best from GPT 5.2 Codex, with that being the frontier coding performance of it, and then the best from GPT 5.2, yes, two different models, they have weird naming conventions, which is the reasoning and professional knowledge capabilities. Put those together, also make it 25% faster, refine it, and now you have GPT 5.3 Codex, which, by the way, is their first model that was instrumental in creating itself. Kind of wild. Also, quick note, the fact that they have the ability to converse with the announcement or any other blog posts, articles that they have is a really freaking smart idea. I have no idea why Anthropic does not do that. I want to be able to converse with this. Why don't you let me? Oh, well, they do let you converse with docs. Okay, that's enough of that. I always feel obligated to at least mention some of the benchmarks, at least mention some of how they marketed it in their announcement. But now it's time to actually get down to brass tacks and see how it codes. Now, since we are butting them up against each other, I am going to be using Zed, who is a sponsor of today's video, but also an editor that I just genuinely love to use. Written in Rust, by the way, which is also the Rust codebase that we will be implementing a feature on testing these models. However, there's something very important to point out, and that is different harnesses utilize models a little bit differently from one another. Some, it feels more powerful, some less powerful. So what I'm going to do is, thanks to Zed's ACP, Agent Client Protocol, I am able to use Claude Code within Zed and Codex CLI within Zed. So we're using the actual harnesses that are from the same companies as these models because presumably they're optimized for such. And you can see down here that I'm using Claude Opus 4.6, and over here I'm using GPT 5.3 Codex Extra High. And the only reason I have two windows open is just because I think it looks nicer on camera. Because frankly, if I wanted to, I could have as many threads as I wanted with Claude Code, Codex CLI, Gemini CLI, or I could add open code, what have you. You can also use any model you want via an API key, as well as any that Zed has available on their plan. It's also going to be a very clean way to look at the diffs. All right, let's start with the TypeScript code base. This is Jetty, a link intelligence platform I've been building, beta coming soon, but right now, bugs. And bugs make for good tests. And you see these little bubbles that are appearing and disappearing on screen. Well, there's a bug that Opus 4.5 hasn't been able to solve. When I switch over to a new workspace and then I come back, every bubble that spawned while I was away is just frozen on screen. They all pile up in the DOM and then vanish all at once. That's issue 21 in my GitHub, so I'm going to prompt it with fix issue 21. Here's the description. I've got Opus 4.6 on the left in Zed, Codex 5.3 on the right, and both are running through their native harnesses via Zed's agent client protocol. And something that I like to do when I'm using Zed is use this little follow agent button right here where I can see the actual code changes occur in the buffer, not just in the agent window, which I guess is just personal preference, but it's something I really like. And the results are in. Codex did not fix it, whereas Opus did. And the funny thing is, the Codex code actually looks cleaner. It's textbook reactive React, state-driven, use effect on state change, but it doesn't work. Opus, on the other hand, went imperative. One use effect, one closure. When the document is hidden, stop. When it's visible, start, done, that's it. And the reason Codex failed is because it used on animation end right here as the cleanup callback. Now, browsers freeze CSS animations in background tabs, right? So that callback never fires while we're away. The bubbles spawn, but never get cleaned up. Whereas Opus used set timeout, which still fires in the background. It's throttled, but it fires. That's why it works. And I'll admit, it's not good code by React standards, but it is the option that works. It's actually kind of a hack to use set timeout to manage DOM element lifetimes instead of just letting React state-driven model handle it. And Codex actually had the right idea, reactive, state-driven. It just botched the implementation. And really what it comes down to is the fact that we have one use effect over here for Opus and two use effects over here for Codex. So Opus can see everything within that closure, but the visibility effect here and then the interval effect down here, and those two can only communicate through a React render cycle, and React isn't re-rendering when the tab is in the background. Opus works, Codex was leaning towards the React way of doing things. Which do you think is better? Now that was just a little CSS animation bug that I wanted to see if they could fix since 4.5 couldn't. Let's give it something a bit more vast. So I want password protected links in Jetty. You create a link, you set a password, someone clicks it, they get a password prompt and enter the password. And I gave a pretty broad prompt for both. Both models got the overall flow right. They have bcrypt hash on create. Strip the hash from API responses so the front end only sees a has password boolean, rate limited verification endpoint, click tracking after unlock, and the Cloudflare worker checks for a password and falls through the tan stack so we can actually render a UI if that link has a password. Both of them do that. But here's where they diverge a little bit. So Codex built this whole verify password function that handles bcrypt, SHA-256, and even a plain text fallback with constant time comparison. But the thing is, this is a brand new code base. Every password in here is going to be bcrypt. There is no SHA-256. There's no plain text. So it's defending against hash formats that don't exist. It's not wrong. I appreciate the defensiveness of it to ensure nothing breaks in the future, but it's more than what we need right now. It did do one thing Opus didn't though. It refactored the duplicated link resolution logic into a shared helper. That's what we call good code hygiene. Opus bcrypt.compare. That's it. One line, every password is bcrypt, so it's all you need. UI wise, I mean, they're both fine. Opus is a little more polished, but what's most important is that it does an optimistic update on has password after editing a link to add a password, so the UI doesn't wait for a refetch. It's a small thing, but it's a nice touch. So who wins this one? It's very, very close. I'm happy with both of them. Opus was simpler code. Codex did a little bit more, and it was better organized with the shared helper and things of that nature. So I don't know. What do you think? Now on to Rust. We're going to be working on Zed's own source code, multi-million lines, real architecture, and to limit confusion, I switched to the CLIs, Claude Code on the left, Codex CLI on the right, and I'm still going to be using Zed to review the diffs. Because if I had one Zed working on one work tree, another Zed working on another work tree, and then I would have to build the Zed instances for each of those changes that we made, we'd have 4 Zeds on screen, and I think it would be very confusing. And I'm currently having them write an implementation plan as we speak. And this is issue 46178. The Git panel uses different indentation than the project panel. You change the project panel indent to 40 and it updates, but you go down to the Git panel, it doesn't move because it's hard-coded at 16. I put both models in plan mode so they can create an implementation plan on how to tackle this issue, and both models planned the same approach. Instead of creating a whole new Git panel indent size, just have Git panel respect the value of the indent size for the project panel. Except with Codex 5.3, implementing it with this clone double unwrap deal, which actually goes against the coding guidelines I gave it, and Opus 4.6, choosing this unwrap or implementation, which is the safer option. So in other words, while it hasn't been implemented yet, a half a point for Opus 4.6, because the plan, while the same idea, better implementation. I'm not really keeping score. And if you're wondering, Codex finished way faster on the implementation plan as well as the code fixes than Opus 4.6. And this was consistent across almost every test. 5.3 Codex is just quicker, at least in my test today. However, when I compiled the Codex solution, it errored. So I took the error, fed it back into Codex for it to patch it, and it worked. While Opus, on the other hand, compiled clean first try. And if we go ahead and test each one, right now we're at indent size 10 on the project panel. Let's make sure nothing changed here. So we go over to 40 and we're good to go. Okay, so let's go back to 16 actually, because 16 was the hard-coded value for the Git panel. So if we look at this and we go over to the Git panel and we come in here and we change this, before it didn't change whatsoever. So let's see if it changes at all. Let's see if we do 10. It changes. That's not how we want it to change though. 40, it changes. And actually you can tell that it is respecting the true indent size. The indent size for this Git panel is the same for this. You can tell between the distance from this line and this line to this line in the edge. But that's the issue, is that the Git UI is reading from the edge. That's why it's hard-coded at 16, because that brings this line directly under the folder, whereas this stays under the folder and all of these get pushed out accordingly. So it is doing exactly what we asked it to do, to be fair. But let's come over to Opus 4.6 and see if this one works. So they both work as intended. The Git panel indent size is respecting the project panel indent size. It's just not exactly what we had hoped in our mind. Let's take a look at the actual code. So looking at the code, there are a few interesting things. One is that Codex made a completely unrelated change. It looks like a good change. And it was this entire file of selections collection.rs. But it wasn't in the plan. It's not in scope whatsoever. I don't know if it just saw it and pulled a Sonnet 3.7. It was like, oh, I'll fix this while I'm here. The other two files, however, the getpanel.rs is exactly what we expected. You can see a lot of the changes here, but with the most notable, where we have what we previously discussed, this type of unwrap versus this unwrap right here, where you can see indent size for the project panel is none or empty. We have a default size to go back to. Whereas when using unwrap and you have a missing indent size value, it does not default to 20 or whatever. It panics. And not only that, we have agents.md in this code base, which are the coding guidelines for Codex to follow. And right here, it says avoid functions that panic like unwrap. Codex is supposed to read that file before doing any work, and I guess it read it, but it just ignored it. So not only did Codex give a worse solution as well as change something that we didn't ask it to, but it also disobeyed our own coding guidelines. So while Opus took longer, it did compile on the first try, and the code is better. Yeah, I'm going to do another Rust one. Remember, this isn't to be able to do the craziest tasks in the world is to see what tasks can get done in a larger code base. Because if we were to black box a lot of these tasks, it could probably knock them out, but it can do a lot when it's not dealing with so much context. And that's really what I wanted to test, because most of us are going to be working in 1, 2, 3 million line code bases, if not more. And we need to ensure that the AI can actually handle those things and do the little features or the big features for us, or at least help us do them. Next is another Rust feature in the Z code base to add configurable letter spacing to Z. So some fonts are too cramped, for example, and there's no way to adjust it. And on this one, just for fun, I ran 3 implementations. I ran one in the Codex CLI, I ran one in the Claude Code CLI, and I ran another in the Claude Code through Z, all on separate work trees. Well, the one in Z was on main. And I'm going to go ahead and say yes, auto accept edits, which, as you can see, changed down here from plan mode to accept edits. And I'm going to go ahead and follow Claude Code so that when it changes files, I can see inline the actual file theme.rs that it's changing. So you can see it added that hunk there. Easily one of my favorite features, because when you're working over here and you're only in the CLI, I can't see what's running past me like this. Not at first glance. And this one is a little bit different because all of the plans came back a little bit different, thus making their implementation of this feature a little bit different. All 3 of them worked. You're able to space the letters out as well as go negative if you want to. But architecturally, they are very different, especially since I accidentally told Claude Code CLI to do buffer only and not buffer and UI, whereas the other 2 models did both. And Codex is an interesting one. If we take a look at the code, it created separate wrapper methods that wrap the existing shaping functions. So it does work. It avoids touching existing call sites. So it makes for a clean PR, which is another commonality I've seen with Codex 5.3, is that it really wants to ensure no merge conflicts and that everything works properly and that all PRs are clean. But the issue here is that now we have 2 versions of every method that do the same thing. And every future caller has to decide which one to use. But on the plus side, like I said, it's non-breaking. No existing caller needs to change unless it wants letter spacing. Whereas Opus 4.6 and the CLI did the opposite. It just added the parameter, which is more churn in the PR, but it's cleaner after it merges because every single caller is explicit about what spacing it wants, even if it's just pixel 0. And then for everything else, again, it's different architecturally. Opus 4.6 actually took line wrapping into account because as letters get further and further apart, well, you don't want it to go off screen, it's going to have to wrap. Whereas Codex did not account for that, but also had better surrounding code and polish, like tests and docs and VS Code import and things like that. So again, I prefer the Opus 4.6 solution over the Codex 5.3 solution. It's just more complete, although the Codex 5.3 one is not bad. And I did have it work on some Java code bases, one small, one large, and the results were more of the same. So it felt redundant just going over it. And I also had to do more work that Opus 4.5 couldn't solve on that TypeScript project, with Codex 5.3 actually fixing something that 4.5 really struggled with time and time again. So in short, I like both models. They're both good. So there we have it, the 2 best AI coding models to date, which I can definitively say. Now, when it comes to Opus 4.6, I think it is better than 5.3 Codex. And this is just one man's experience, but I tested it on a lot of different code bases, a lot of different types of code and languages, and it was better every single time, if not most times. The increase over 4.5, while very incremental, it is not the same increase from pre 4.5 to 4.5 that 4.5 is to 4.6, but I do notice going back and forth less. A task that may have taken 2 or 3 back and forths, I'm noticing that type of task is being done in one shot by Opus 4.6, which is very much welcome, because Opus 4.6, it's like the better something or someone gets at coding, the less personable they are. And Opus 4.6 seems to follow that, because conversing with it feels worse. It feels like you're trying to talk to that really, really good developer that isn't really all that social, whereas 4.5 was more of a mid or senior level software engineer who is good at what they do, but also had some social skills remaining. And honestly, I am going to miss that. A negative when it comes to Opus 4.6 over 4.5 is that it seems to take forever. I had some tasks where it didn't, but it definitely takes longer than 4.5. And for every single test that we did, except for some that took the same, it took longer than GPT 5.3 Codex. As for Codex 5.3, I am re-recording the previous recording, which is why I'm wearing a different shirt, because I've been using it more over the past 2 days than I had when I previously started, solely on the TypeScript code base that we were working on in this video, and I really like it. It has been feeling better to me than Opus 4.6 on that code base, but on the Java Spring code base that y'all did not see, the large one that y'all did not see in this video, because I'm not allowed to show you that code base, Opus 4.6 produces better code. Now, maybe this is because I'm a better Java developer than I am a TypeScript developer, but Codex 5.3 is really good at the TypeScript stuff. But the other thing about Codex is that it's a whole lot cheaper than Opus. I mean, we know that's the case. However, I don't really hit my limit on the $100 Opus Claude Max plan, but I also never hit my limit on the $20 ChatGPT Plus plan that I'm using using Codex 5.3. Long story long, you can't go wrong with either of these models. Just figure out which one you like better for your type of development. But that's what I think of these two models. They are incremental improvements over their predecessors, nothing revolutionary, but I kind of just want incremental improvements at this point. AI coding models, there's not much that I could throw at these new models that the previous models couldn't solve. These models just happen to solve them a little bit faster. And when I say faster, it's because there's less back and forth. Opus 4.5 would get the work done with a little bit more back and forth that these two would get done with just 1 or 2 prompts. But again, this is just one man's opinion. You try out the models for yourself, the type of coding that you do. Let me know your experience when it comes to coding with these models down in the comments, and I'll see you all in the next one. This one was fun.